First of all, hi everyone. My name is Vladimir. I'm a software engineer at Penta, online bank for small and medium businesses. And today we're going to be talking about building desktop applications with Electron and React, as per the title.
So, let's get started. What is Electron? I think that's the first question that we need to give answer to. Electron is a platform that enables you to write and build desktop applications using standard web technologies. Basically, at the moment, if you want to build desktop application, you need to use platform-specific languages for if you want Windows, if you want OS X, everything is different. But with Electron, you can just use plain HTML, CSS, and JavaScript and create fully fledged desktop applications for every single popular platform. Also, with Electron is good. It allows you to focus on developing just core application functionality while he takes care of everything else. So your job is just to do the same thing you do when you're creating a web application. You just code, put your code blocks, and native processes, everything else is handled by Electron. These are examples of some of the most popular applications outside based on Electron, as the list is way, way, way longer. But I think that these couple of examples are going to show you the picture how Electron is really actually popular. So, what are the main differences between web and desktop apps? AKA, why do we need desktop web apps, or why do we need web apps? Well, the first difference is accessibility. With desktop apps, you need to install them. If you want to update them, you need to uninstall and then install again. That's not the case with web apps. But on the other hand, for web apps, you need internet. For desktop apps, you don't need anything. Once you install it, it's there. Also, the benefit of web apps is you run in a browser. You have a couple of different browsers, but they're pretty much the same. While Windows, Linux, and Mac OS are really, really different platforms, and it's really hard to write single code base that can effectively run on all platforms. And maybe the biggest difference is a web application cannot access your operating system in ways that it cannot modify your file system. It can read from the file system, you can upload an image, but you do not have access to the underlying OS, because basically your web app is just something that is rendered in a browser. And now we came to the part to explain how does Electron works, and hint is just a wrapper. Electron is basically, just a wrapper. It wraps your web application into a process and allows you to run it as a desktop application. That's done via combination of these two technologies, Node.js and Chromium rendering engine. Node.js is in charge of spawning the desktop app process, while Chromium rendering engine is in charge of actually painting what you build in your web app. So when you combine those two, you start process, you get the application window, and then Chromium uses its superpowers to render your web application into a desktop app view. Three main components of Electron are main process, rendering library, and your web application. But I kinda was too lazy on that slide, so I already kinda told you this. So, yeah, and this is more visual, this is a visual representation just to get a better grasp of it. So you have a main process spawned by Node.js, and inside of that main process, you can have many, but in most cases you have only one renderer process. In each of those renderer process, there is one web application. And that's how you got your desktop app. So when you start spawn the Electron, your main process, that first component, is used to start everything and to communicate with the native OS. Because, as I said, Electron is a wrapper, but if we want to use the full power of desktop app, it needs to have a way of communicating with the underlying operative system. A main process is in charge of that. Like, he's in charge of that type of communication. He's in charge of creating all of these renderer processes. Basically, he's the main parent. You start him first, and then he takes care out of everything for you. When you started the app and created the main process, the first thing main process does is he creates application window, because you need to show some content to the user. That application window is something that has render process inside. Render process is actually the thing in charge that paints your app, because like Chromium is rendering, Chromium as a rendering engine takes care of that for you. So when you spawn browser window and render process inside, your application starts painting, and that's pretty much it. This is just a recap, because I'm aware that I put maybe too much content on previous slide for everyone to digest. So this is just a quick recap. So main process, Electron logic, render process, application logic, and now we came to maybe one of the most important parts of Electron, and the part that enabled us to actually have Electron, and that's called IPC. IPC is it's a collection of mechanisms that allows you to share data. For example, everybody knows, like, who here uses Google Chrome on a daily basis. And you have a couple of tabs, like 5, 10, like if you want to access a new web page, you're not gonna open a new window, you're gonna spawn a new tab. Those tabs are, and they spawn new processes. Like, it's not one Google Chrome process, and when you go to your task manager or activity monitor, you see only one process. Every time you open a new tab, Chrome generates a new process. That's one of the main reasons Chrome eats so much memory from your computer. But why is that? For example, if you go to a torrent or some website that has malicious script, if you don't have separate processes, malicious script can infect one tab and then spread to the whole process, and then freeze the whole process, and then freeze your computer. For example, I suppose like everyone here used Pirate Bay or something like that in the future, in the past, sorry. Like, do you know that Pirate Bay sometimes use the miners? So while you are on Pirate Bay, they use your processor or graphic card to mine Bitcoin or any other cryptocurrency. And that kind of things can really eat all of your processing power from your computer. So we have, every time you spawn a new tab, it's a separate process, and when Chrome sees that one tab is behaving the way it shouldn't be behaving, Chrome just cuts that tab off and avoids infecting everything. But if you have if you have main parent of Google Chrome's browser and you have 10 separate tabs that are separate processes, you need to have a way to communicate between those tabs, because they are separated, but they're all part of the same browser. And that's why we use IPC. IPC is basically like a bus, as you can see. And if you want to communicate, if Google Chrome wants to communicate to any of the tabs, or in Electron case, renderer process, it can communicate directly. But if a renderer process wants to communicate to other renderer processes or to the main process, it can't do that directly. So you need to go to the IPC, send event, and then wait for your parent to say, okay, you can send your message to whoever it was intended to. IPC is a big part. Like, I know this sounds like I diverged off topic, but this is important to understand because IPC is a big part of Electron because we have Electron process, the main guy who is helping us to show desktop app, and we have a separate process that is called our web application. And if we want to target operating system from our web application, we need to send an event to the main process. Main process is doing that for us and just sending us the response. So that's why we use IPC to communicate between our web application via main process to the underlying operating system. And this is how that looks in practice. You have application view. Imagine this like HTML CSS page with a button. And let's say that you want to get OS info to see like your current, I don't know, how hot is your processor at the moment. You can't get that because you cannot access directly to your operating system. But with Electron, you can do it. First, you need to send an event to the main process. Hey, I want to do something using native OS. Or say, hey, get me that info from native OS. And then Electron says, okay, give me a second. Electron turns back to the operating system, does the requested operation, and then when he's finished with the calculation or whatever you requested, he fires an event. Okay, here's your result, and you can update your view. Everything in Electron and in desktop applications who use Electron is handled this way. So you can access everything you want, but for operating system specific logic, you target Electron's main process, and then Electron's main process returns data for you. He does all of the dirty job. You don't care about native implementation. You don't care, are you requesting something from Linux or Windows? Your job is just to say, I want to get this finished, and Electron takes care of everything else and returns you the result. Enough about Electron. What is React? I think, like, is everyone here familiar with at least what React is? Yeah, I suppose so. So, like, I think I'm gonna skip some further detailed explanation about this. Rather that, I'm gonna show you the code, or actually how that works, because I think that's maybe the best way for you to understand everything. So, I took the liberty to create some basic dummy React app. This is just a standard web code, like nothing you haven't, even if you don't have experience with React, you can understand like basic div, like tags, CSS. This is just a standard web app. Okay, how do we make this web app into desktop app? Like, can we do it that simple? Actually, all we need is to install one library and to add 2 files, and that's it. First thing we need to do is to add Electron starter file. This file is in charge of starting that main process we've been talking about. So this file when I now start my web application, this file is going to be started first. He's going to create a process. He's going to create a window in which we are going to render our application, and he's going to handle everything that we want to request from our application to the underlying operating system. So we need to I added quite a couple of comments rather than going out and explaining every single line of code. And another important thing is you need to add a specific wait script. Why is that? As I said, you are starting two processes. You need to start the Electron process to show your desktop app, and you need to start your web process to render your application inside of that app. But you need to sync between them, because you can have a problem. For example, if you start one process before the another, you're going to see a blank screen, while if Electron starts first, your users are going to just see blank screen until you start your web app. Or if you run your web app first, like, you're going to see spawn process, but Electron is going to take more time to adapt. So that's why I created this simple script, and it just synchronizes the two processes. So when we run Electron, we're going to run the web app at the same time, and only when both of them are ready, we're going to show you the actual application. The next part, if we want to add Electron to our React app, so we said these two files, is fairly simple. We need to add Electron dependency, and we need to create a script when we run npm run Electron that is going to say start Electron. Because why do we need to do that? When we run the command start Electron, Electron library is going to call this Electron starter. We said that here. Like, when you run start Electron, first thing you're gonna do, execute this. And when we start executing this file instantiates all the libraries we need, creates a main window of your application, does all the kinds of weird logic in here, but basically how big do you want to be your screen? Do you want to have node integration? From which URL do you want to serve contents inside of your screen, etc., etc. And at the end, it says, okay, I did everything. Now give me the URL you want me to serve in my application window. So, and that's it. Like, if I now go and run npm run dev and hope that my demo won't crash, here it is. This is a standard application for macOS. Like, we can zoom it, we can minimize it, here's it again, or we can kill it. And that's pretty much it. Like, basically all you need to create a desktop app is React code and one file and one library. And you can do this for every React project. And the big thing is this code is going to run on Windows, it's going to run on Linux, and you can ship it basically to every type of currently popular operating system in the world, which it's really hard to do using any other standard technology. So, back to the presentation. Bonus. When working with desktop apps, you need to take care and to think about certain things that you need you don't need to think when you're building a web app, because basically what you do, you build a web app, you tell your DevOps guy, hey man, like I want to update it, release it, build it, ship it, and that's pretty much it. Desktop apps, as we said in the beginning, needs to be packaged because they need to be installed on different operating systems. You need a DMG file for Mac, you need I can't remember, exe file for Windows. You need, yeah, and for Linux, like dependent of the Linux you want to target, you need to think a lot about packaging. That's why, like, Electron community developed a really lot of good modules for packaging your Electron application, because Electron at the moment doesn't have automatic packaging support native. So you can use any of those libraries and you are good to go. You can create packaging or distributions very easily. Another thing that you need to think of are automatic updates, because you do not want to say to your user, hey, I have an update, please delete your old app and install a new one every time. You need to allow user to receive a notification, click, and just update your app. Those things you can't do, and you don't have to using standard web apps. In Electron, unfortunately, you have. But for automatic updates, you have both native support and the Electron Updater package. I suggest using Electron Updater package because it's much better and it's longer there. Like, it has a really good community. You don't have to set up a lot of things, and it's just basically magically works. Another thing that you can do with Electron is use native modules, because Electron, as we said in the beginning, runs on Node.js. And you think, okay, why don't I just use native Node.js modules in Electron app? Well, you can do it, but you need to recompile it before usage. Electron process comes with a lot of things, and that's one of the main problems of Electron. Electron process comes pre-bundled with its own version of V8. And when you install some random node library, Electron needs to be certain that he and the node library, they use the same V8 version. That's why when you want to use node libraries in Electron, you need to just recompile it using Electron rebuild, and then they're good to go. There are also other libraries that allows you to use other APIs like Node.java and stuff, but to be honest, I didn't had a chance to work with it much, and I'm not sure how stable it is. What are the problems of Electron? Like, it has some really good points, but it also has some problem, like it's not a silver bullet. The biggest problem with Electron is size and memory consumption. When you're building a desktop application using some standard regular techniques, you build it and and that's it. You don't need to take care of Chromium, V8, and other things that comes with Electron. When you install Electron process, it comes with its own version of Chromium rendering engine. Chromium rendering engine has over 20 million lines of code. It's bigger than some operating system. So basically, when you're building an Electron app, it's like, in terms of size, it can be similar to like building an operating system. And also, Chrome is really popular for having a healthy appetite towards your RAM memory and processor. So Electron apps built with Node.js and Chromium also quite oftenly consume a lot of memory, and consume a lot of your processing power. It depends, like it's not, those are not so drastic cases, for example, that you're not gonna build a simple Electron app and finish up with like 5 gigabytes, like nowhere near that. But if you build a desktop application using some traditional practices, and if you build the same application using Electron application is going to be significantly larger than your desktop app, because it basically comes with your web application, Electron native code, the whole browser, Chromium, inside of it, additional logic, and if you use some native modules or you have some specific logic for various operating system, with that too. And that's one of the biggest problems with Electron at the moment. The other problem is, obvious thing, security. Electron applications are not insecure. They just have more security loopholes compared to traditional desktop application. Because like Electron exists only for a couple of years. It was developed as a MVP, like a, hey, let's try to do this project on in GitHub team. Desktop applications are here like for how long? Like 30, 40, 50, a lot of years. And that's why Electron has some of its own security vulnerabilities that I don't know how to say this correctly, but you have a bigger chance of getting hacked if you're using an Electron app rather than if you use your standard desktop app. So it's not something drastic, but yeah, it's a problem. And that is pretty much it from me. Questions? While we get the mic ready, if anyone has a question, you can just pop your hand and ask away. Ah.
Okay, okay. You ask away, and then I'm gonna go through the questions.
Well, what would be the use case of having a Electron desktop app?
Well,
With all of its cons, you said, a lot of memory usage, security.
well, it depends. Like, it's first of all, it's not insecure. It's just less secure than standard desktop apps. And also, as you said, like as you saw, a lot of big applications are built on top of Electron. So like it's just like the fact is it's less secure but not unsecure. The pros are you can write one. More people are familiar with using standard HTML, CSS, JavaScript syntax, and you only get to write one code, and it's going to run on every platform, and it's much easier to maintain it. It's much easier and faster to build it because you're using traditional web technologies. But the use cases are in most when you want to build something fast. Because if you're a startup and you have an idea and you want to start, you need to build a desktop app. Like, is it easier for you to just do HTML, CSS, React, and pack it in Electron? Because, like, if you're a startup, nobody cares about extra 10 or 15 megabytes in your download size. But if you want to do it like the proper standard, the old way, like you need to find a developer, you need to... It's much easier and faster to develop and maintain things with Electron. And also, like it's on a small scale, but Electron also proved to be really efficient on a big scale, because Skype is on Electron, Slack is on Electrons. Like Slack is worth 23 billions, and they're still like, use MacBook. Yeah, go in Slack and just do Command R. It's gonna reload the page.
Okay, thanks. Can you use ACL bridge connector in Electron app?
ACL bridge connector.
Yep.
To be honest, I never tried that. I never had a use case to use it, so like I really don't know an answer to that question. Because I don't know what would be the use case to use ACL bridge in Electron app.
Okay, thanks. Can IPC use CCT for intermediate process switching?
For intermediate process switching?
Yep.
I think that I'm gonna answer like I didn't had. Why would we have the need to switch between processes? Like, yeah, we can switch between processes if we spawn a couple of processes. For example, if you want to spawn multiple windows, but then the thing is, if we spawn multiple windows with Electron, multiple application windows, every of those windows has its own identifier. And then if you want to switch between processes, you just target different identifier. Like IPC on target process and just say where do you want to send your event.
And why do you think are all Electron apps sluggish?
Well, I don't think that... Here's the thing. I don't think that Electron apps are sluggish. These are just facts. Like, they're a bit bigger than the standard web apps. Like, they're not sluggish. They work really good. Like, you used most of the Electron apps in your regular life. They can operate really good, but when I was talking about some cons of Electron, those were just comparing to the traditionally built desktop applications. Like, and also when I was talking about cons, like it's just comparing. Like, it's a bit bigger than the standard app. It's not like all of them are going to destroy your system memory.
Can we run apps that are not hosted locally with Electron?
Not hosted locally. You mean if you want to run something from a remote URL, you can do it. Basically, just you have in here. Here's the thing. In this main Electron, you have main window that start URL, main window that load URL. This line of code says, hey, main window, load this content inside of our app. And you need to give it URL to your index.html page, basically to the root of your application. Now, this can be on your local machine, this can be on wherever you want.
And can Electron apps be compiled for mobile phones?
I think that I know some people who were doing that, but I'm not sure how that's not so good practice, because you have much better technologies and much more performant technologies who are designed specifically. The Electron is designed for desktop apps. Like compiling for mobile phones, it would be a bit... There are technologies that are specialized for that, and doing that in Electron, like, I'm not sure how stable that would be.
Okay, thanks. And does Electron support WebAssembly?
I think no. At least, like, their Electron team is like constantly updating and adding new features, fixing bugs, optimizing performance mostly, and they're like quite active with the new versions of Electron. But for WebAssembly, I think that they don't yet support it, because the Electron team is now mainly focused to, as I said, they're aware of all the problems Electron has, and they're focused on fixing that. And they try to optimize memory usage and performance with every new release.
What would you say are the biggest advantages of Electron and React over Code and Angular?
Well, you can use pretty much everything. Like, it's only up to your personal preference. Do you like React, Angular, or whatever framework do you want? Electron can work with everything. I personally prefer React because it's easier and faster for me to develop with React rather than using Angular. But in the end, you can use everything for Electron, from HTML, CSS, Angular, React, Vue, everything. You just need to give index HTML to your load URL. That's it.
It is using Node.js, so is it single-threaded app?
Yeah, it's single-threaded app, and it communicates asynchronously, because you can send synchronous events, but you can also communicate asynchronously using your IPC protocol.
Okay, quite a few questions here actually. I mean, you finished too early, allowing people to ask around. So how does the performance or resource footprint of an Electron compare to traditional desktop apps?
Well, I think that I pretty much answered that one until now. Like, the reason the Electron is bigger lies in the fact that it ships a whole browser with him. And that browser, it's Chromium, and it has its own consumptions and restrictions when it comes to memory usage and performance. So, like, I think that I'm pretty much answered that.
And how does the install or update process work? Is there an option to patch installed app without uninstall or install processes? It's too overkill for large apps.
Well, install process works the way like you can send a notification event, and basically the biggest use case you're going to have is to go with the clean uninstall and install everything. You have a really good interface packager, and it's done seamlessly. It's pretty fast, and it works the way like you send a notification, and you from your server, hey, I have an update for you sitting on this, let's say, S3 bucket. And then in your application, if you use like some library for updates, you have a listener that takes a parameter, basically like a cron job, and it listens for an event sent from you. And when it receives an event, hey, you have a new update, you can download that update from the bucket and just do uninstall and install it again.
Okay. Does Electron work with other frameworks, or React is the only option?
As I said, Electron works with any web technology. Like, I can just create code, ordinary index HTML, and put it here. Using it with React and using it with any other framework is a benefit, because you develop much faster. Especially React. React is good because React has some really good libraries for interacting with Electron, and React has some really good packages. You can download boilerplate packages for React that has you just download the package and everything is set up for you. Like, something like you have create React app, if you're a React developer, that creates your Webpack configuration and everything. And you have Electron React boilerplates that allows you basically like just clone it, and you have ready desktop app. You don't need to think about this file. You don't need to think about the processes. You don't need to think or set up anything. You just clone the repo, code your web app, and everything else is taken for.
Okay, thanks. And the last question for today will be any experience with native module usage?
With native the biggest problem with native modules usage is they are sometimes buggy. Like, it's not Electron's fault, but like most of the JavaScript community is a really active community. NPM is blooming, like you have millions of packages. GitHub is really active. That's not the case for other native modules or other communities. And it's quite often, if you want to use some native module, you're going to have a really big problem because it's not maintained, you don't have a proper documentation, it has some bug that no one will solve because it's not relevant. So I suggest, if you need to use some native module, use only Node.js module, because it's easier for you, if you have a problem, to get help.
Okay, thank you.